solving distance, rate, and times problems using linear equations. So rate times time equals distance. These ones, again, sometimes you have to solve for a variable other than the question, what the question asks. So be careful that you're going back and looking to see what does the question really want you to do, what did I solve for. But basically, we're using rate times time equals distance and trying to set up some kind of equation, whether they add up to something or whether they're equal to something, so that I can solve for one of those things. Two trains leave the station at the same time. One headed west, the other headed east. Something like that. The westbound train travels 100 miles per hour. The eastbound train travels at 90 miles per hour. So, the rate here is 100, the rate here is 90. How long will it take the two trains to be 494 miles apart? Well, we know we have to take the rate times the time. They left at the same time, so their times are going to be the same. So 100 times t would be this distance, 90 times t would be that distance. We know the total miles apart, 494, so 100t plus 90t is going to equal 494. And if we combine our like terms, 100t plus 90t would be 190t equals 494. So all we have to do in order to solve this one is to divide by my 190. And so if you divide that out, you get 2.6. 2.6 hours then is how long it would take them to be 494 miles apart. Number 5, Deborah drove to the mountains last week. There was heavy traffic on the way there, and the trip took 6 hours. When Deborah drove home, there was no traffic, and the trip only took 4 hours. If her average rate was 22 miles an hour faster on the trip home, how far away does Deborah live from the mountains? So this time she's going to go to somewhere, then she's going to come back. Again, I want to think about the rate times the time, and that this time the two distances should be the same since she went somewhere and came back. So the times on this one is easy. There's heavy traffic on the way there. It took her 6 hours. On the way back, it only took her 4 hours. I'll do that. My rate. If her average rate was 22 miles an hour faster on the trip home, I need to write something in there for the rate. I don't know what the rate was on the way there. I'm just going to call it R. On the way home, she went faster. So her rate would be R plus 22. 22 miles an hour faster. So my equation, R times 6, or 6R, is the distance on the way to the mountains. Here I'm going to take my 4 times my R plus 22. I can multiply that out. 4R plus 88 then would be my distance on the way home. So now I have my equation. If I'm going to solve that, I got to subtract my 4R to move it over. So 2R equals 88. I'm going to divide by 2. R equals 44. Now, the question doesn't ask for the rate on this one. The question wants to know how far away does she live from the mountains. Now, I could put this 44 into either one of my sides because those two distances would be the same. But the first one obviously is going to be easier to do. Not that it should make any difference. So if I take 6 times 44, that will give me the distance that I went to the mountains, right? 6 hours at 44 miles an hour would give me how many miles? 264. 264. Number 6 then. Two trains leave the station at the same time, one headed east, the other headed west. The eastbound train travels 16 miles an hour faster than the westbound train. If the two trains are 510 miles apart after 3 hours, what is the rate of the eastbound train? So, the eastbound train travels 16 miles an hour faster than the westbound train. What should I rate for my rate of my eastbound train?
16 plus W.
I'll rate it W plus 16. That means the rate of my westbound train is going to be just a W, right? So one's W, the other one's W plus 16. What are my times? They both went for 3 hours, right? So times that one by 3, times that one by 3. So 3W plus 3 times W plus 16 should be the total miles, 510 then. So 3W plus 3W plus 48 must be 510 when I use my distributive property there and get rid of my parentheses. Combining my like terms, 6W plus 48 equals 510. Now I'll let you subtract for me, just so I don't get the wrong number. I got to minus my 48 to move it over to the other side. So 510 minus 48 would be 462. 462, and if I divide that by 6, 77. So the westbound train is going 77 miles an hour. The question asks, what is the rate of the eastbound train, right? So I found the westbound train, I got to find the eastbound train. We knew that one was going 16 miles an hour faster, so I've got to add my 16 to that, and I would get 93 miles an hour. So watch for that. A lot of times on these ones, you'll solve it for one thing and have to put in some other answer, so just pay attention to that.